I'm Ann Cosgrove, the Editor-in-Chief of Facility Executive Magazine, and this webinar is presented by Sika Corporation. Before we get started, I would like to cover a few housekeeping items. Please note the control panel that's on your screen. This is where you can submit questions via the question box in that panel. You can send in your questions at any time, and our speaker will address them after the presentation or perhaps during, if it's quite relevant. Also, please note the orange arrow on the left side of your control panel. Clicking on that arrow will either expand or collapse the panel, so please be sure it is expanded so you can access the question box to talk with us. If at any time you experience a technical difficulty, please also use that question box to send us a message and someone will get back to you right away. Now I'd like to introduce your speaker today, Stan Gravleen. Stan is Senior Vice President of Technical Services at Sika Corporation Roofing in Canton, Massachusetts. He's worked in the industry for more than 30 years in various technical, sales, and management capacities in the U.S., Canada, and Switzerland. Stan's participated in technical committees and standard writing bodies in North America and Europe. He's written numerous articles and papers and is a speaker at various national and international industry events. Stan's a member of Professional Engineers Ontario, the Roofing Consultants Institute, and ASTM International, from whom he received the William C. Cullen Award in 2011. He's currently active on committees within SPRI, the Chemical, Fabric, and Film Association, and the International Council for Research and Innovation in Building and Construction. He has a Bachelor of Applied Science in Chemical Engineering from the University of Ottawa and a Master's of Business Administration from the International Institute for Management Development, Lausanne, Switzerland. Finally, before I hand it over to Stan, I'd like to let you know if you indicated during the registration process for today's webinar that you were interested in obtaining one AIA Health, Safety, and Welfare credit, and if you noted your AIA member number on the registration form, we'll be submitting that information on your behalf. Also, if you indicated that you're interested in obtaining a certificate of attendance for the webinar, we will email that to you directly. So please allow up to a week for us to process and email that certificate to you. So thanks again for signing on today. And with that, I'm going to hand it over to Stan.
Thank you very much. Welcome, everybody. Thank you for taking the time to join us this afternoon. We will move right into our presentation, Understanding Eco-Standards and Eco-Labels for Non-Residential, or otherwise known as Low-Slope Roofing. This is an AIA presentation, of course, as was noted, and is eligible for one credit from the Health and Safety Welfare category. The presentation will be provided to those who request it later from facility executives and will be available upon demand. And of course, copyrighted material. So in this day and age, we all hear all these terms, buzzwords such as green, sustainable, environmentally friendly, all natural. We see that in our consumer purchases and we see them in our professional lives as well. And we see them in roofing, and that will be the top of our discussion today, will be to look at some of the formal labels and standards that exist for non-residential or low-slope roofing materials that are relevant to environmental, sustainable, and other attributes that we may be interested in for our building products. So the objectives of the program today, we're going to talk about some examples of self-declared environmental claims and how they've evolved to third-party verified claims and environmental attributes. We're going to look at an overview of some of the most common standards that are out there and labels, and we'll talk about the differences between them. We will go into some depth talking about the ANSI, the American National Standard, NSF 347 Sustainability Standard for single-ply roofing. And we will wrap up with a discussion on some of the credits that are available through roofing materials and roofing systems for achieving credits within LEED and Green Globes. So green construction materials are a big business. You've probably all seen these kind of headlines. Market for green building materials set to soar through 2019, or even more dramatic. Worldwide market for green construction materials will grow from $116 billion in 2013 to $254 billion in 2020. What does it all mean, and how do we sort this out? We obviously all want to do the right thing, but how do we choose the right materials and address these questions? So there are various ways to assess the ecological profile of construction materials and construction systems. At a product level, we can look at single attributes, and we'll show some examples later, life cycle environmental impacts, and we'll talk about that as well, and multivariable comprehensive assessments, which get more and more sophisticated as we go down that line of attributes and standards. The other way, of course, is to look at full buildings, and there we're looking at rating systems like LEED and Green Globe, and we will touch on those as well. So let's move into what is probably the most common of the single attributes that are known to all of us, recycling and recycled content. Clearly, as a benefit to recycling material, we reduce the need for new raw materials through recycling back into our products, both at a pre-consumer level or at the point where they, in the manufacturing facility before they go out to the construction site, and at the post-consumer level at the end of the service life when the materials can be reclaimed and possibly recycled. Are they equally beneficial from both levels? Possibly. Optimally, obviously, we want to recycle the materials from our plants and our production facilities, and that, of course, is good. Even better is if we can take back the materials at the end of their service life and recycle those as well. So if we can combine these materials and process them into something of a finished good is ideal. And then in a perfect world, what we try to do is recycle them back into the same type of material that they originated from and provide the same sort of life expectancy. In this case, trimmings from a production facility as well as material at the end of its service life on a roof are combined and used and processed into new roofing membranes, which will then go out and provide decades more of service. Ultimately, the ideal closed loop recycling, if you will. Like with many environmental claims, there are a lot of claims made about recycling, particularly as it relates to end of service life recycling. Many vendors will claim that theoretically they can recycle their material at the end of the service life. Technically, they can recycle it at the end of the service life, but in practice, may be another story altogether, and there's often evidence that it's not necessarily done despite some of the claims. So what we'd encourage people to do is request that vendors who make such claims provide them with third-party certification of these claims, and that can be claims for recycled content, for example. It could be claims for bio-based materials and many, many others. And entities like UL Environment will certify those claims. They will validate those claims by auditing facilities, following the supply chain of materials from being removed from a roof to being processed to being integrated into a membrane, for example. So if that is something that is of importance to you, we would encourage you to ask for a third-party verification of the claim. Another example of a single attribute that is often referenced in the sustainability world, particularly in the roofing world, is the cool roofing area. For a couple of decades now, cool roofing membranes have been acknowledged as providing energy savings benefits and having an impact on reducing the urban heat island effect. In the early days, manufacturers simply tested their own materials and they reported their own values in their data sheets and so on, possibly based on different test methods, one from another. So it was difficult for the users to have a proper appreciation of the actual value and the benefit and so on. Over time, Energy Star got involved. Energy Star created a program for roofing materials, and they took things a step further. They called for reporting of the more relevant aged values because, of course, roofing materials will soil over time, and the reflectivity values that are reported for new materials will not necessarily be those values that are experienced in the field. So that was definitely a giant step forward, as well as creating a database for this data. They allowed considerable flexibility in acquiring the field data for the aged material, and they allowed for self-reporting. So there was some progress there, better metric using age values as opposed to new values, providing some definition on how to achieve those values and providing a database, all the while still allowing manufacturers to self-report their data. Then over time, the Cool Roof Rating Council came into being, specifically as a result of California's Title 24, where they mandated for prescriptive applications using cool roofs in the state of California for energy savings purposes. Cool Roof Rating Council was founded as the independent body that would manage the data that would be the basis of the Title 24 claims in California and the ratings and so on, and is now commonly referenced and used throughout the country for different purposes, including for Energy Star. They developed sampling, testing, and standardized aging protocols, which put everybody on the same path and using the same methodologies and the same testing methods, which makes the data more comparable. Most importantly, they required that all testing be done by approved third-party laboratories and that the aging be done at approved third-party weathering farms, defined weathering farms in 3 distinct locations. They developed a database, which is an excellent source of cool roof data on the reflectivity of materials, the aged and new reflectivity of materials, emissivities, and so on. And they, most importantly, went through the process to become an American national standard, which provides a lot of credibility, provides the ability to reference this data in all types of government programs, for example, and is the epitome of the type of standards that we'd want to reference, and we'll come back to that throughout the course of the presentation. So that kind of gives us a very good example of something that started off on a very low level, self-reporting, very few guidelines, to now a very formal program where people that use the data can trust the data and have very good sources of data available that are comparable amongst different materials and so on. But nonetheless, that is still a single attribute metric. Now, there are certainly some pros and there are certainly cons to single attributes. The pros, of course, are that they're simple, they're easy to understand. You either have recycled content in your material or you do not. You achieve a certain reflectivity value or another value. One product may have a higher value than another. Very clear, very easy to do. If that's what's important to you, then that allows you to focus on that. If recycled content or organic-based raw materials are important to you, or reflectivity is important to you, you can focus in on that, get good data, and very often that data is third-party verified or certified. There are, of course, some significant shortcomings. Obviously, that's a very narrow focus on a single attribute or maybe a couple of attributes. Generally, what can happen and will happen is by doing so, by focusing on a single attribute or maybe a couple of attributes, we might ignore a number of other equally and often more important environmental attributes. So certainly a benefit to them, but certainly some very real limitations. And again, if you are going to use those, we encourage you to look for values that are available through third-party testing, third-party documents, rather than simple claims. The next level of life cycle or life cycle assessment is the next level of sustainability standard or reporting. Life cycle assessment involves a technique to look at a product's life cycle impacts through the entire stage, from raw material extraction at the very least and always, and to the end of the service life in some instances, and we'll cover that in a little greater detail in a moment. The idea is to compile an inventory of material and energy inputs. So the material could be raw materials and so on, and then of course energy, and as well as outputs, which could be releases, which could be consumption of water or other materials, or releasing things into the environment. And that's done across a number of environmental impacts, and impacts are associated with each of these, and then they go into a calculation methodology that gives us a metric or a quantitative measure of a product or a system's environmental impact through various stages. Life cycle assessment reports are very complicated documents. The process is very complicated. You can see here some of the metrics are a little alien to us: non-renewable primary energy, global warming potential, acidification, photochemical smog. Historically, these reports were done by consultants with their clients, both of whom would decide on the ground rules. And like most things in life, the devil is in the detail. And often the details were very hard to find in these reports, and it's very difficult to assess the quality of the report, the validity of the conclusions or the data that was presented. And the reality is these are very complex documents, and really they're written by scientists for other scientists, and very difficult for architects or building operators or designers and others to comprehend and to use the data. So the International Standard Organization, recognizing that challenge, developed protocols on how to conduct life cycle assessments and how to report their results. These are called environmental product declarations, probably a word you've heard. They're becoming very, very popular for a variety of reasons. And we'll talk a little bit about them, where they come from and how they are generated. Typically, a third-party certified EPD gives you a very credible, consistent tool for assessing life cycle impact data. They've been in use in Europe for a number of years now, going back probably to the late 80s, early 90s at the very least. They are now recognized in both LEED and in Green Globes, and they are being considered by the Government Services Administration and other federal agencies like the Department of Defense as a basis for environmentally preferred product purchasing policies and decisions. Environmental product declarations document products' life cycle environmental impacts and are LCA based. In a sense, they standardize the LCA, the life cycle assessments, and instruct on how to report that data. The key is that they allow for transparency, with regards to a product's environmental impacts. So they're segment specific, so that means within a given type of construction material, insulation, roofing membranes, wall panels, glass, or whatever the case may be. Typically, they will have the following elements in each of them. They will have a declared unit. So in the case of a roofing material, that declared unit would be one membrane of membrane. So all the data that you will see reported will be for 1 square meter of membrane. The one thing you'll note with environmental product declarations is they are typically done in metric units. 1 square meter of membrane is about 10 square feet of membrane. Now, that is a declared unit, and it does not reflect physically what happens in the field, which is a functional unit. So a functional unit may be defined, in this case, sticking with the example of a roofing membrane, as 1,000 square meters or 10,000 square feet, for example, which would include seams and overlaps, any materials you might need to create those seams. If you're using a rubber-based sheet, you would need adhesives and tapes and primers and so on, and they would be included. And depending on the system you're defining, whether it be adhered or mechanically attached, would also include the components, be it fasteners or adhesives, for example. Beyond that, it will define a number of the technical aspects of the environmental product declaration being considered. One is the impact categories. There are about 24 impact categories, and many are not practical in all cases. Some are very, very specific and may apply to very specific types of products. And secondly, these environmental product declarations are very expensive to develop, and one tends to, through the product category rules, narrow the impact categories down to the ones that are most important and have the most impact for a given type of material, typically anywhere from 3 to half a dozen. It will describe the various life cycle stages being considered. We'll describe the life cycle assessment models. For example, in the US, we typically use the EPA's Tracy model for life cycle assessments. Europe would use different models, and so on. And the idea is to ensure that for a given segment, thermal insulation, for example, that all the environmental product declarations are done in a consistent manner and reflect the appropriate elements, such as the appropriate impact categories for the given segment. In the low slope roofing industry, we're actually well served. We have all the main components, or the most important components that we use in low slope roofing, already have product category rules. So the bituminous roofing materials, modified bituminous, built up bituminous asphalt shingles, for example, have product category rules. Single ply roofing membranes also have product category rules, as well as the thermal insulation. So we can cover all the key components of a low slope roofing material, low slope roofing system with environmental product declarations. This shows the number, shows all of the life cycle phases that could be considered in an environmental product declaration. So if we start on the left-hand side of the schematic, you'll see we have the product stage. Going to the right, we have the construction process stage, followed by the use stage, and then the end of life stage. So if we go back to the left again, you'll see the different A stages. So we have raw material supply. So literally we're looking at all the impacts related to extracting the raw materials from the ground or from the earth, processing them to the degree they have to be processed, any transportation between where they were extracted, where they were processed, and where they might be transported furthermore to the manufacturing facility. All the impacts related to the actual manufacturing of the product, and this would be considered a gate. So the product stage, for example, all the elements I just described would be one gate, for example, a product stage. Then you would move on to the construction process. Then you would also look at the transportation, and you'll see that come up many, many times, the transportation. Transportation, of course, has a significant environmental impact, and the more and the further you have to ship materials, the greater the impacts, and those are considered. Then we would have any energy or other materials that are involved in the actual installation process, and they would also have impacts, and they would be classified and quantified here. So we would have our second phase of construction process stage, which would be phases A4 and A5. And then we would have the use stage, or the life cycle stage, or the life stage, excuse me. So we have use. There would be possibly maintenance required. As we all know in good practice, we should maintain our roofs. We should maintain a variety of our building systems. That would be captured here. Any repairs that may need to be conducted throughout the life cycle of the material would need to be replaced. When you do an environmental product declaration, typically a service life of a building will be declared, typically 50 or 60 years. And in that stage, if your roof would last 20 years, you would have to replace it 3 times in a 60-year building. So that would be included in there, and that would be taken into account. In some cases, you may be able to not necessarily replace something, but simply refurbish it. For a coating, for example, you may simply overcoat the original coating. If there are operational energy or water used throughout the life of the product, that would be considered as well. And that typically is more for mechanical equipment and other things. These are very generic life cycle stages, and they apply to all sorts of materials and systems. So in roofing systems, we generally wouldn't have operational energy usage. You might have operational water usage if you have a vegetated roof and you need to maintain it through irrigation. And then the end of life stage, as the name implies, is what happens at the end of the service life when you deconstruct the assembly and demolish it or the building. You'll again have to transport the materials that you've generated. You will have to process them in some way and dispose them. And in that, of course, could be transporting them for recycling and then reintegrating back to the start of the process as a new raw material. EPDs are going to force all of us to learn a very new and strange set of names and nomenclature. So if you look here, these are the most common life cycle indicators that are used with construction materials. So if we look at the top of the list, global warming potential, which intuitively I think we're by and large we are familiar with, calculated in kilograms of carbon dioxide equivalent. Acidification potential, again, a little more somewhat obvious, acid rain, calculated in sulfur dioxide equivalents. Eutrophication potential, that's the impact of the nitrogen resulting in blooming in lakes and things like that. A little less intuitive to us. Smog creation, of course, we're aware of kilograms, ozone equivalent, ozone depletion potential, kilograms of CFC 11. CFC 11 was a blowing agent used in thermal insulations and was also used in refrigerants and cooling medium in fridges and freezers and things like that, which, as you may recall, was found to have significant detrimental effects to the ozone layer. And the idea here is that there are other chemicals that contribute to global warming, other forms of acids that affect acidification, and so on. And the idea is they're all normalized in the appropriate equivalent, if you will, as you see here. We will always look at total primary energy consumption in the various stages, which includes non-renewable fossil energy or non-renewable nuclear energy in megajoules, renewable energy, solar, wind, hydroelectric, and geothermal, renewable energy biomass, and then we will also look at material resource consumptions. How many kilograms per square meter of membrane of non-renewable materials are consumed, how many kilograms of renewable materials, how much fresh water is consumed in liters for that declared unit of product, and how much waste is generated for that declared unit of product. The life cycle assessment consultants will do these calculations, and they'll do them for the various stages. So we have an example here for a 60 mil membrane, a generic membrane, and you can see the various criteria or indicators on the left, the units going to the right, and then each of the product stages, in this case product stage A1 to A3, which is the manufacturing, construction process stage, and end of life stage. Note there's no use stage, and I will come back to that a little later. So this is going to take some time to get used to. I don't know about you, but I have trouble imagining what 7.1 times 10 to the minus 7 kilogram CFC 11 equivalence really means, or even worse, 6.2 times 10 to the minus 9. That means 0.000000062 kilograms of CFC 11 equivalent. So this is going to take some getting used to as we get exposed to these and as we interpret these and decide how best to use them. And the same as we go down the table there for non-renewable fuels and renewable fuels and material consumption and so on. So that is the most essential part of an environmental product declaration, and that is the type of data that you will get from such a document. So the environmental product declarations are available in a couple of ways. They can be done on a generic type of level. So you can get an environmental product declaration for PVC roofing membranes, for example, which is what's shown at the bottom of the little stack of 3 environmental product declarations, or TPO or EPDM, which is at the top, or for polyiso insulation, which is in the middle there. These are typically done by trade associations, and the specific document covers only those products that are listed within the environmental product declaration. So if a manufacturer sells or markets a product similar, for example, a PVC, and says, we try to tell you, here's my environmental product declaration. If they're not actually listed in there as one of the companies that participate in that environmental product declaration, it is not considered to cover their product, and they are not compliant with it and cannot use it. And then, of course, environmental product declarations can be completed and are available for a specific product from a specific manufacturer, which of course is even better, more accurate, more specific to the product that you might be using. Now, environmental product declarations are a step further from single attributes. They cover many, many attributes of the product over different periods of the life cycle, but there are still some challenges and some shortcomings with regards to environmental product declarations. Environmental product declarations, if we are to do a cradle to grave which is from extracting raw materials to the end of the service life and either disposal or incineration or recycling, can only be done if we have a reference service life. And reference service life is essentially the life expectancy of the product. Life expectancy is the biggest single driver of any life cycle assessment. And the challenge is that we don't have a standard definition for something like a roofing membrane to say that the reference service life of product X is Y years, 10 years, 20 years, 30 years. And that, of course, is very, very important if you want to do a proper cradle to grave environmental product declaration. And at this point, it's probably a good point to remind people, one of the things that we can't lose sight of as we strive to be ever more sustainable is performance. And at the end of the day, the most important sustainable or sustainability attribute of a product is its durability. And the longer something lasts, particularly when we're talking about building materials, and more specifically about building envelope materials, where it is very expensive and very difficult to replace them, durability and life expectancy are very, very important. So in the short term, because we really do not have a standard definition for reference service life, the environmental product declarations will likely be cradle to gate. That would be specifically the manufacturing of the product and possibly up to the installation of the product with the associated accessories of fasteners or seam tapes or adhesives or something like that. At this time, certainly in the roofing industry, there are no cradle to grave environmental product declarations that are ISO compliant. A number of them were done many, many years ago before these product category rules were developed, and one would really not be able to use those today because they're not built on the standards defined by the product category rules. The challenge with that is that, according to the International Standards Organization, is that cradle to gate environmental product declarations are not intended and not suitable for comparison. And the reason for that is if product A has, for discussion's sake, 10% lesser environmental impacts than product B, but if product B lasts twice as long, that's not captured in a cradle to gate and can give very misleading results. So the International Standards Organization cautions that cradle to gate environmental product declarations should not be compared one to another, or you should not make product decisions based on that because it can be misleading without the cradle to grave element or the reference service life element. So now moving on to the next step in our evolution of eco-labeling and eco-standards, we're going to talk about ANSI, which stands for American National Standards Institute, NSF 347. NSF 347 is the Sustainability Assessment for Single-Ply Roofing Membranes. The assessments are product-specific. Unlike environmental product declarations, you cannot do a sustainability assessment for a group of products because it's very specific to a material, very specific to the aspects surrounding that material, the company that manufactures it, how it manufactures it, and a variety of other things that we'll go into detail here in a moment. So it is an American national standard. Again, that means that can be referenced in government purchasing policies, can be referenced in building codes. In fact, it is now, and I'll bring that up in a moment. Green Globes formally recognizes the ANSI standards. There's a suite of them, which I'll describe at the end here, but specifically as it relates to roofing materials. And in fact, now the International Green Construction Code in the 2015 edition does reference these ANSI NSF standards. These multi-attribute standards are referenced to define sustainable materials, including NSF ANSI 347, which is the standard for single-ply roofing membranes. The system is set up, or the standard is set up in a pretty simple fashion. The standard is divided into 5 categories: product design, product manufacturing, membrane durability, corporate governance, and innovation. The picture to the right here is the cover of a copy of a version of the Professional Roofing magazine. They wrote an article on the standard, and if you're interested, you can get at that at their website, www.professionalroofing.net, and that can give you a very good overview of this standard. So the first area assessed within ANSI NSF 347 is product design, and that goes from the development process. As part of the audit process, you have to demonstrate that the development process within the company has formal checklists and formal processes to ensure that sustainability and environmental impacts are always considered in the development process for new products. You have to demonstrate the use of sustainable inputs like recycled materials and bio-based products and so on. The use of those materials provides additional points. Failure to have those materials does not cost points, but does not gain points. There is a section on chemicals of concern. So there are 6 lists, such as the International Association for Research into Cancer and a few others. And if you have raw materials that are on those lists, you do not get points. But if you do not have any of those chemicals, you can gain additional points for not having those chemicals on these reference lists in your product. There's an obligation to understand your suppliers, environmental policies, and whether they're complying with all environmental regulations, whether they have environmental plans and management processes in place. They look at the use of pre- and post-consumer membrane recycling, and they also consider, if you do recycle materials, that you're recycling them into durable goods, ideally into the same material, but if not, into goods that are long-lasting. The longer lasting the goods you recycle into, the more points you can acquire in this particular section. The next section is product manufacturing, and as the name implies, has everything to do with how the materials are produced. The manufacturer has to demonstrate that they have environmental policies in place and how they manage those to ensure that they are implemented and that they are in fact used and used as described. Additional points are available if third-party audits are done of the environmental management system, and additional points if those are published, those results are published. There are a series of points for emissions and usage, water, energy, raw materials, and air. These points are set up in such a way as to provide points either for minimizing the use of these resources, demonstrating reduction over a certain period of time, particularly over 5 years, and the greater the reduction, the more points that are allocated. The standard is in some ways challenging because there are diminishing returns in doing that, and it becomes more and more difficult to keep up those levels of reduction in any of those resources. But that is one of the fundamental goals of the standard, is to encourage companies to continually improve their processes to reduce the environmental impacts. The next area that is very important to the standard is durability. Going back to the point I discussed earlier, proven performance in the field is extremely important and a huge driver of environmental impacts. The standard allows for points for proven performance in the field, and the longer the material has been in use in the field and it can be proven that it has been performing in the field, the more points are allocated to that section. There's consideration of the membrane's energy surface contribution, specifically as it relates to reflectivity and energy savings, roofing energy savings. The standard assesses the company's maintenance programs for the roofs. Clearly, the roofing system is more likely to reach its expected service life if it is maintained and if there are clear guidelines on how to maintain the roof to achieve that projected service life. There are points for having a field quality management system even the best of materials will not perform to its expected service life if it's not installed correctly, and manufacturers have to demonstrate that they do go out in the field and they do work with the contractors to ensure that the materials are properly installed. And then there are points for ongoing monitoring of the performance of the material in the field in different climate zones to make sure that the material is performing, continues to perform, and that any findings in terms of aging mechanisms and so on are considered in the development process, again with the idea of always looking to continuously improve the product and reduce impacts. Corporate governance is important to the standard with regards to labor policies. Most of the policies covered in here are really regulated in the US, and most companies will of course comply with these, but there are prerequisites to meet and there are points to be had for that. Employee relations and employee development. You have to demonstrate that you are training employees and continuously striving to improve your employees' work skills, work set, and expertise and knowledge. Safety, of course, is very important, both with regards to the employees and with regard to the stakeholders who may be in the area of the production facility. Public outreach and education, demonstrating involvement in industry groups, whether they be trade associations, standard writing bodies, providing educational seminars like the one I'm doing right now, for example, and documenting those and reaching certain levels. And then investment in the community, which of course is a duty we should all have through our corporations to invest in our local communities. And those things are assessed as well under the auspices of the corporate governance section. And then there is the possibility with a general kind of category called innovation, and that would involve either dramatically exceeding the levels of the various metrics that are described in the standard and achieving much higher levels, or achieving them with new and innovative techniques that result in even less burdens on the environment, or extend the life expectancy of a material or something like that. And there's the opportunity there to achieve additional points for innovation at the auditor's discretion. So there are 123 possible points. The points are distributed as we see here. As can be seen, the biggest is product design. And again, that comes down to the raw materials that are used, the idea of designing for the environment and designing to minimize environmental impacts over time. Second highest in terms of percentage of the point is membrane durability, for all the reasons I've spoken of on a number of occasions so far. And then product manufacturing, of course, which has an impact on the emissions and the use of energy and other natural resources. And then at a much lower level, innovation and corporate governance.
Excuse me, Stan?
Yep.
Hi, it's Ann. I'm sorry to break in. I just did want to ask a question while you were kind of talking about the elements of the standard here and how product is so important. And as you know, I want to make sure to get this question in as we have about 15 minutes or so left.
Okay.
I wanted to ask you if you could quickly just mention how does the ANSI NSF 347 compare, I guess, just kind of the high points with environmental product declarations? Are they to be compared, side by side, or does
Sure.
The ANSI standard offer, something beyond, or just if you can quickly comment on that?
Yeah,
Thank you.
The ANSI standard goes way beyond the environmental product declarations. In fact, you can get points within the ANSI standard for having environmental product declarations, but it goes way beyond that, as I mentioned, with a focus on proven performance, with a focus on development, approach to development, and ensuring you're always improving the product and moving forward and doing continuous improvement. So the EPDs are an element of the ANSI standard, but they are it's only a small part of it, and the ANSI standard goes in much greater depth and detail. So it is really the most comprehensive of all the environmental that we have, and as I indicated, includes performance targets, levels for various metrics, and really is a great platform for ongoing improvement and has a strong focus on functional performance. The ANSI standard is only one of a number of standards. There are also a whole suite of the similar standards for carpet wall coverings, resilient floorings, and others, and they're all referenced in the International Green Construction Code. I'm running a little behind time here, so I'm going to speed this up a little bit. As most people are probably aware of the whole building rating system, the most important or the most known is the United States Green Building Council's LEED. LEED just introduced their V4. The members agreed to V4 in 2013, but really only came into being recently, and now all projects have to be registered with LEED V4. There are a number of categories within LEED where roofing materials can contribute directly and indirectly. Some of these are summarized here, and I'll show some concrete examples. The number of points will vary depending on the LEED rating system you're choosing, whether you're doing it for healthcare, new construction for schools, retail, data centers, and so on. And that's why you see a range of points there for the various metrics. Some of the most common related credits for roofing: using vegetated roofs can contribute points in a number of ways to sustainable sites. Credits with regards to rainwater management, a very important criteria as we have greater and greater problems most of our city with the rainwater runoff from our hard surfaces like roofs and paving. They can also contribute to the water efficiency credits if the green roof does not require extensive watering and sprinklers, for example. And they are now another way of achieving the urban heat island reduction credit. The most common way of achieving the urban heat island reduction credit, of course, is to use white, highly reflective roofs, and the simplest way to achieve that credit. Name is a little misleading. Indoor environmental quality, that also includes a lot of the materials that are installed on roofs, and the idea is to have low emitting materials, so low VOC content materials, and you'll see that come into play with roofing adhesives, for example, roofing coatings, sealants, and other roofing chemicals. There are some new credits that were introduced this year: building product disclosure and optimization. The first one allows for environmental product declaration. So this is the first formal use we've seen of these. As can be seen, you can achieve partial points by using generic industry EPDs. Let's set off the timer. Sorry about that. Or you can achieve greater, but you can get a full point, if you will, for each product you have that has its own manufacturer-specific Type 3 third-party certified environmental product declaration. Then there are a couple of other building product disclosure and optimization credits. We won't go into these here. They are very complex and very challenging. They require extensive documentation. Not many manufacturers, if any, are ready to meet those criteria yet. And in fact, industry is working with the USGBC to see if there's a better, simpler, easier way to achieve the same results. So LEED V4, with regards to roofing materials, with the exception of non-compliant volatile organic compound or solvent-containing products, lead-based roofing and flashing and hot mopped asphalt has no limitations on the use of any types of low-slope roofing materials currently available on the market. The second whole building rating system, not quite well as known as LEED, a lot newer, Green Globes. Green Globes was selected by the Government Services Administration in October of 2013 as the second certification system that could be used on federal projects, the first, of course, being LEED. The big difference, a significant difference, not the only difference, is that the Green Globes is an American National Standards whole building rating system, which, contrary to perception, LEED is not. And though it is newer, it is gaining momentum quickly and is being recognized by a number of government agencies and leading private institutions throughout the country. And as in LEED, roofs can contribute to numerous points throughout the rating system. Similarly, heat island effect reductions and stormwater management through the use of green roofs for both of those, or with reflective roofs for the urban heat island effect reduction. There is a strong focus on energy, some obvious things like thermal resistance and amount of insulation, but other less obvious but equally important, the importance of detailing at penetrations and roof edges to ensure there's no air leakage, using air barriers, and of course, as in LEED as well, the opportunity to have renewable sources of energy, which can be roof mounted and can contribute points in that way as well. For example, through the use of rooftop mounted solar. There is the possibility, again, as there is with Leave It as well, to look at whole building performance by looking at whole building LCA, for example, which can be done with the Athena Institute's impact calculator. However, in the absence of that, there are prescriptive methods through the use of environmental product declarations and the use of the various NSF ANSI standards for the sustainability assessment of the various building components are another path to achieve those points. As in LEED, there are credits available for managing construction waste and recycling and for managing the use of volatile organic compounds and other materials that may affect indoor air quality even during construction. Additionally, they have points available for acoustic comfort, and in large low slope buildings with large low slope roofs like schools and so on, that can be significant, and roofs can contribute significantly to that. And the criteria here are summarized in the attached table, or the table shown here on the screen. So we all want to avoid greenwashing, and we would suggest that the best way to do that is to, wherever possible, reference American national standards in your product specifications or your construction specifications. And when you're looking at some specific metrics or specific attributes that you want to look at, we strongly encourage you to insist on certification from credible third-party entities like NSF, Underwriters Laboratory, ASTM, etc. The whole area is a veritable alphabet soup of acronyms, and we've only touched the tip of the iceberg here. There are many, many more. We've only looked at the most common, but these are things that we're going to have to understand, and we'll learn to understand over the years if we are going to build sustainably. So I am not sure if we have any time for a few questions here. If we do, certainly I would welcome them.
We do. Thanks, Dan. And thank you for that great presentation, chock full of information. I do have a couple questions here, and we do have a few minutes. So the first one I'll ask is a kind of a general one that I would imagine applies to a lot of our attendees today. So for someone who has, all their buildings are existing and they're not really looking into new construction at any point in the foreseeable future, the question is, this means I'm re-roofing these about every 15 to 20 years. So which one of the standards that you've talked about is best suited for a re-roofing project or program?
That's a great question. The LEED and Green Globes, of course, are geared to whole buildings, and they do have, both of them have programs for existing buildings for major retrofits, but nothing that really is suitable specifically to roofing. So if you're just doing roofing, you really should be looking at the sustainability profiles of the materials, and you can do that through the ANSI standard and at a lower level through the environmental product declarations. There has been some efforts to try and develop LEED-like or Green Globe-like rating systems strictly for roofing because it is such an important thing, as 3/4 of the roofing is re-roofing, and that's struggling a little bit right now. So stay tuned for that, but otherwise I would recommend the ANSI standard.
Thank you. And also, talking about coatings and cool roofing, you talked some about that and the resources that have been made available over the years. So we have a question here. My buildings are in Michigan, which is considered northern climate. I looked into coating our built-up roofs with a reflective coating, but was told it's better to leave them black and to keep them warm in the winter. Should I not coat them white? Or I know that's a question that swirls around the industry a lot.
Sure. Yeah, there's an intuitive sense that if cool roofs are highly beneficial in cooling dominated climates like the South, that dark roofs would be more beneficial in northern climates that are more heating dominated. And that's not necessarily the case. And there have been numerous studies that have shown that even in cool climates or heating dominated climates, cool roofs can actually still be very beneficial in providing net energy savings Most recently, in the past year, there have been 2 different studies done, one by the McGill University Heat Island Group, and they looked at roofs in Alaska, Minnesota, Milwaukee, Toronto, and Montreal, and found that in all cases there were still net energy savings using a cool roof in those climates. There was another important study done by Princeton University where they did the same thing, looked at roofs in the northeastern U.S. and found the same thing, that even in the northeastern U.S., even with the high levels of insulation that are typically used there, cool roofs can be beneficial there. And the reason for that is that in the winter, the days are a lot shorter, the sun is lowered at the horizon, a lot less intensity, a lot less energy. In a lot of the areas, there's snow on the roofs. And the net effect is that the amount of sun, the sun's intensity in the winter months is typically about 20% to 35% of what it is in the summer. So that heating effect is nowhere near as significant as we would think it would be on a dark roof. And the net effect is that although you'll save less energy in the north than you will in the south, there's still a net positive benefit of using a cool roof even in northern climates.
Thank you. Thanks. So it looks like we have time for about one more question. So I wanted to ask about recycling. If you're recycling, meaning I guess any of the manufacturers, and please speak to Sika's work if you would like. If you're recycling old roof membranes back into new roof membranes, doesn't the old roof material affect the durability or longevity of the new membrane that comes out of that?
Sure. Can understand why people might be concerned about that. There's a couple of points there. One is we've been doing this a long time. We started doing this in Europe in the early to mid 1990s and continue to do that to this day, and have been doing it here in North America since 2005. Prior to doing that, extensive research was done to make sure that we wouldn't affect the quality of our material, because the long-term durability is the most important attribute of it. And we do that by a couple of ways. One is by putting the material, the recycled material only goes in the underside of the sheet, so it's not in the weathering part of the sheet, number one. And number two is extensive testing was done that has allowed us to determine how much material we can put into the sheet without affecting any of its properties, weldability, expansion, contraction, low temperature flexibility, and things like that. So there's a lot of science behind that, and there are now, 15, 18 years that we've been doing it, and billions of square feet of roofing installed that we've confirmed that there's no detrimental effect to using the recycled content as we do.
Great. Thank you. Thanks for that. So so it looks like we are out of time. So I do want to thank you, Stan, again for the great presentation, and of course all our attendees for listening and sending in questions. We will be posting this webinar on our website at facilityexecutive.com, and also it will be on Sika's website at us.sika.com. And thank you again to Sika Corporation for sponsoring the webinar. Thank you, everyone, and have a great afternoon.
I posted my email address there if anybody has any questions on the last slide.
Perfect.
If somebody wants to contact me directly, they're welcome to do that. Thank you, everybody, for attending.
Thank you, and thanks, Stan.
Bye now.
Have a great afternoon.
Thank you. You too.